This is the lesson for days 1 and 2 of Unit 2B, Exponential Growth and Decay. So what we are talking about is the average rate of change. And if you notice this, we talk about the change in the output over the input. Our notation this time has to do with the function notation. But if you basically look at this, you guys, it's really just a slope. But the words average rate of change mean a little bit different because we're not always going to be talking about a line. So when we have this over specified interval, it can give us an idea of whether the values or the function are increasing or decreasing. And that's going to be something that's valuable as we move on. So example number 1, we are given that function of a line whose graph is the 2x minus 1. So this says, find this average rate of change between 0 and 2. So if we actually looked at this on the graph, we have the 0 amount and go over to the 2 amount, and 1, 2, 3, 4, 1, 2. So if you recall, remember, it's going to be the change in y over the change in x. And so in this case, we get 4 over 2, which is 2. Now the thing about that is, you guys, you're not going to always be able to specifically know from a graph like the slope. So of course, if it isn't a line, you would need to look at the change again in the output, change in y over change in x. Now, in order to do this, just for general sake of calculating the values, it is going to be the input, comma, the output of 2 points or interval. So, find the average rate of change from 0 to 2 again. We're going to look at that. And if I look at those coordinate points, for the 0, my output was the -1. For my 2, the output was a 3. So in this case, we would just calculate the average rate of change between those points, and we would have ended up with the number 2. Okay, so example B, find the average rate of change, the same function from -1 to 2. So in this case, we would have our coordinate points. -1 is at -3. 2, again, is at 3. So we are calculating what that change is. And so we're going to go the average rate of change is the output over the input, and we would have 6 over 3, which is, in fact, 2. Okay, on to the next examples. So, we have a function that this time is based on using the table. So when we do this, these create a coordinate point. So if I'm going from 0 to 2 for my interval, 0 to 2, and these are the output values for each of those, because there might not be a constant rate of change when you're looking at a table of values. So our 2 points would be 0, our output is 5, our next point is the input is 2, the output is -3. So to calculate the average rate of change, we're going to do the output, subtract the other one, 2 minus 0, we get -4. The next one, between 1 and 4, our point at 1 is 1, 1. Our point at 4 is -11. So we would have average rate of change. We would have negative 11 minus a 1 over negative 4. Oops, supposed to be positive 4. 4 minus 1. And that would also give us negative 4. Next one. What are we doing? 3. And it gives us the value of negative 7. And we have 4. Again, that's negative 11. So our average rate of change, negative 11 plus 7 over 4 minus 3. We have negative 4 over 1. So again, we get negative 4. Now, this is a input-output table that actually ended up giving us the same rate of change. But that is not going to always happen. So consider the quadratic function on the right. And we want the average rate of change between 1 and 3. So if we look at 1, our output is 0. And if we look at 3, our output is negative 4. So our average rate of change is going to be the change in y over the change in x, and we get negative 2. So for B, we're looking between 2 and 5. So at 2, our point is negative 3. At 5, our point is 0. So again, we are doing the change 0 minus a minus 3 over 5 minus 2, 3 over 3, and we get a 1. So if you notice right off the bat, A and B do not have the same average rate of change. And if you think about this, if you look at a parabola like this one, it does not have a constant. Because of the curve, there's different rates of change. So let's go ahead and find 2 and 4. So 2, our output was negative 3. And 4, our output is negative 3. What do you think is going to happen on this one? They both have the same output value. So it looks like we are going to get a negative 3 minus a negative 3 all over 4 minus 2 plus plus. We end up with 0. All right, example number 5. Given this quadratic, which is reflected, find the average rate of change between 1 and 5 and interpret what it tells you about the function. So what we are going to do is get those coordinate points. So at 1, I need to plug the value into here. And I would get 2. And then the next one is we are plugging in 5. And we get for the output negative 6. So now we are calculating the average rate of change between those two. Negative 6 minus 2. 5 minus 1. What do we get? Negative 8 over 4. So we get negative 2. What does that tell us about the function? We are decreasing in that interval. Now the next one, we're going to do between negative 5 and negative 2. So again, we have to figure out the output based on what the function is. So let's figure those two values out. First one, we get 7. The second one, we get 12. So here we go. The average rate of change. 12 minus 7 over negative 2 minus a minus 5. What do we get? We get 5 over 3. What does that tell us? It tells us it's increasing.